viewers, welcome back to the another session of our data structure journey. Today we are going to learn how to perform the insertion sort, and here we are implemented in the C language. So this is the outline of our video. First we have to understand what is the insertion sort, then how the sorting algorithm works, then what is the exact algorithm, then how we are implemented in the C language. Then we will discuss about the time complexity as well as the space complexity. Then what are the advantage, disadvantage of the insertion sort. Then we go for the application with the conclusion of this video. This is the outline of our video. So let us understand what is the insertion sort. By the name insertion sort means the entire list is divided into two parts. First part we consider as a sorted list, which initially we store the first element of the unsorted list. Only one element means we have to consider this is a sorted one. So first element of the list we take as a sorted data, and from the remaining second part, the second part is called as the unsorted data. Then what happened? Each and every iteration we take one element from the unsorted data and put into the proper place of the sorted list. So why it is called insertion sort? Because we have to take an element from the unsorted data list and insert into the proper place. That's why it is called as the insertion sort. So let us understand how the algorithm works. So here what happened? The array is consist of four elements. So for example, this is 0, this is 1 index, 2 index, 3 index, 4 index. Now this list of elements we make as a two part. First part we can consider as this one, and this is the remaining. So this is the unsorted part, this is the sorted part. So we can make like as a this is the sorted, this is unsorted. So first element we consider as a sorted one and remaining concept. After that, for each and every iteration, we take an element from the unsorted and we put into the proper place. Now, next question, how it works? Let's understand how it works. So first we make as a array. So this is our first element. So this is 0 index. So whenever we have to perform the operation, we have to start from 1 index to n minus 1. Here n is 5, 4 minus 1. So now 3, 4. Now what is the element? So here what happened? First case, this is 10, 45, 25, 5. So now here what happened? We have to take this value and store in a separate location. Separate register variable, for example, we make as a 10. Then what happened? We have to search. We have to check whether it is in proper place or not. So now we have to consider which value. Temp is 10. Now we have to assume that this element is not present here. This element is not present. Now we have to go check the 25. If 25 is less than or greater than. If it is greater than, then what happened? This element we have to shift into the one position right. Then here what happened? We have to shift into two position means right now this is 25. Previously it was 10. We have to assume that it is not. Then in this position, this 0 index, we have to insert the 10. Now what happened? We have to insert into the 10. So now we insert which value? 10 value. So this is the first iteration is over. After first iteration, this is our sorted array, 10, 25 sorted. Now we have to take this element. So now temp store which value? 45 value. It stores the 45 value. Then what is our objective? Our objective to put the 45 into proper place. So how to do it? Here, this array is sorted array. So as it is sorted array, no need to move to this way. We have to move to this way. We are here move to this way. So if it is 2 means in what is the index 2? So 2 minus 1, that is the from 1 index means from previous index we have to traverse. So we have to check whether 25 is greater than 45. No, it is not 45. Then what happened? We don't have to traverse again left side because it is already sorted. If it is not means we assume that this is the proper position. So we have to again copy to this 25 here. So this is the third element is over. Now third element, this sorting is over right now. Then what happened? If this sorting is over now, so now We have to take the next element. So next element is 25 right now. So 25 it is present. So it is 25. So whenever it is 25, then what happened? This is 45. So index is 3. So from which location we have to start? Index minus 1. So from this onwards, we have to check. 45 is greater than 25. Yes, it is true. If it is true, then what happened? We have to shift the 45 to this location. Then what happened? We have to make. So now what we have to store here? Here we have to store the 45. Then what happened? Then we have to check 25. 25 is greater than 25. No, it is equal. So if it is equal, so then whenever it is not greater than, so simple, we have to store here which value? The temp value. What is the temp value? Temp value is 25. Now, up to this, our elements are sorted or not? It is already sorted. So now what happened? We have to move to the next iteration. Next iteration means 25. So what is 20? Sorry, next iteration means the temp value is 5. Here the value is 5. So now we have to search proper position so that we can insert the value. 5 means we have to check. 4 index up to 3 index we have to start. So here what happened? So we have to search 45 is greater than 5. Yes, it is. If it is true, then means we have to shift this location. So if we have to shift this location means what happened? Now this is 45. Here also 45 right now. We are not deleted. Then we have to search this element 25. 25 is greater than 5. Yes, it is true. If it is true, then means we have to again shift this value. So here what we have to do? Here right now it is 25 is shifted to this location. Again we have to move to the previous node. So 25, it is 25. If it is 25, then we have to check whether 25 is greater than 5. Yes, it is true. If it is true, means again we have to shift this value to this value. So once we shift this value, right now 25 is shifted to this location. Now we have to go to the next value, previous value, 10. 10 is greater than 5. Yes, it is true. If it is true, means we have to shift here. Means now again we have to shift this value. So now this is 10. Now, what is the index? Right now, the index is 0. So, this is the our ending point. So, if it is 0 means we have to simple put this value here, this value. So, now we have to put into the this. So, now, so this is the 5. Now, 5, 10, 25, 25, 45. So, our elements are already sorted. So, what we concluded for, so entire list is divided into two parts. First part is store the sorted element, remaining parts so store as the unsorted. For each and every iteration means number of iteration. So what is the number of iteration? I equal to 1 to I less than equal to n I plus plus, because here 0 index is present. From 1 onwards we have to traverse. Then what happened? First element we have to store as a temp. So we store the value in the temp. Then we have to make the j value. What is the starting point of the j? Starting point of the j means if we reach here, if this element, we have to go for the previous element. So j equal to I minus 1. Then what? How much we have to traverse? We have to search the proper location. Proper location is j is greater than equal to 0 means ending point. Or and ai is greater than the aj is greater than the temp. Then only we have to move, otherwise no need to move. Then what we have to do? If it is true, then we have to move the one element to this place. If it is j means it is j plus 1. So aj plus 1 equal to aj. Then each and every iteration from we have to move to the previous way means 2 to 1, 1 to 0, 3 to 4, 1 to. So j equal to j minus 1, or we can make as a j minus 1. Both are same thing. Then once it is done, what happened? We have to insert the value. So what we are making? J plus 1 equal to temp we store the value. So this is the simple. So let us understand the algorithms. The list have one element, then we have to exit sorted, because if it is only one element, no need to go for sorting, we have to exit. Otherwise, we have to, if the list have more than one element, then put the first element inside the sorted list, take the next element and store in the separate variable, that is the we make as a temp variable here. Then put the temp into proper place in a sorted list. So for that, we have to compare the temp with all element in the sorted array backward direction, because backward direction, all the backward elements are sorted list. If the element present in unsorted list is greater than the temp value, then we have to shift to the next location. Otherwise, insert the temp into the that location. This is a simple algorithm. Continue the step 2 and 3 until we reach the end of the list, or we are already got the proper location. So this is the conversion. We can make it as like that. This is the way we have to perform its operation. So let us do the program first. Then only we will discuss the remaining part. So let us do the programming of the insertion search. So to header file we require started input output new. Next one is the main function we have to define integer main. So here we declare one array consists of 50 elements. So size we define that is the 50. For number of elements we want, or the length of array we require to store the n variable. To traversing the loop for the array we require another variable, that is the I. As we know, insertion sort we require two loop. First one is the for loop, another interval is the while loop. So we require two variable, that is I as well as j. Let's see in future if anything is required we can go for it. Printf new line. Then we ask the user to enter the size of array. Please enter the size of array. So we did after one tab. So here I make the scanf %d 1%. So we read the value. Then one by one we have to read the element into the array. So for that we require a for I equal to 0, I less than equal to n minus 1, then I plus plus. So here we ask the user to enter the element. So printf enter the data into array. Actually, this is the format. It is your choice whether you want to or not. Direct, you can go for scanf also. %d ampersand AI. So our for loop is over for reading the value. Then, for example, I want that the data should be printed before the sorting as well as after the sorting of the insertion of. So I can write down printf before sorting the elements of array. It can display like that, it is our choice. So it will print after the one tab. Then here what we have to write down, for I equal to 0, I less than equal to n minus 1, then I plus plus. What we have to print the first %d, because we are going to print integer, then ai. So for each index the alt item will be print. So we print the value. After that, for example, we want in between the data element, it should be one tab, otherwise it's very difficult to distribute. Now our insertion sort is going to perform. So here what happened, we require two loop. First loop for number of element that is equal to number of pass. So means number of iterations. So we make I equal to 0, I less than equal to We don't have to go for I equal to 0 because first elements we make as a sorted array, because in insertion sort what we make the a list into two things. First one is the sorted. So first sorted means zero index we stored. So we make the I equal to 1, I less than equal to n minus 1, I plus plus. So this is the number of it because we have to sorted the unsorted. Initially, first elements we make as a sorted. Then what happened? So first we take the unsorted first element as a temp variable. We have to put into the separate value variable. So we store in a temporary variable, that is temp. So we require one more variable declaration here, that is the temp. So we store the value of AI. Means we now take an element from the unsorted list and we store inside the temporary variable. Then we have to go for the proper place where we have to store the value. So proper the place of the AI means before AI, whatever elements present inside the sorted array, we have to search. So we make the j equal to I minus 1. So now up to how much we have to go? Up to 0 index. So j is greater than equal to 0, or proper position means aj 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 greater than the temp, then only it is okay. Otherwise, we have to insert the value. So for that, we have to perform two operation, that we have to shift. Means if the aj value is greater than the temporary variable, then what we have to do? We have to shift to the next location. So next location means j plus 1 is equal to aj. Then we have to decrease because we have to move to left side. Means backward we have to move side. That's why we make the j equal to j minus minus. Means we have to decrement this value. Then after the loop is completed, we are already reached the value where we have to insert the data. Then what we have to make? We have to make the a j plus 1 equal to temp. We have to insert the value into the proper position. Now temp was the unsorted elements. Now we insert into the sorted array. So this is our outer loop is over. After the data is sorted, what we want? We want the items should be, all the elements should be print. So the same statement we have to copy here and we have to paste here. Only we have to write down here after the sorting. So after the sorting, the elements are like that. Then what happened? We have to write down get ch, then return 0. Then our main function is over. Now let us compile the program and run the program. Okay, sorry. Temp was not declared in this scope. We are not declared. Wait. Oh, sorry, sorry. This is J. J was not declared. We are not declared J also. Okay. Oh, it was showing error, but okay, okay. No, no error. Okay, enter the size. For example, I enter the element into array. So 1, 0, 32. Then here also we require one tab, otherwise it looks not looks array. Okay, before inserting elements are, please enter the data here array. Okay. Here we have to use one tab, then only it will be clearly visible. So let us enter the size is 5. First one is the 90, then 10, then 30, then 20, then 60. Before the sorting, the elements are now it's sorted. Yes, yes, it is sorted. Let us do the reverse order. We push the, then only we will check it. Let's do once again the program. Okay. For example, I enter the size is 10. Then I enter 100, then 90, then 80, then 70, then 60, then 55, 44, 33, 22, or 1. Okay. Yeah, this is the worst case. All the elements are sorted in a reverse order. That's why it was our worst case of the sorting. Okay, we got the result and we are completed our programming. Let us go back to the our time complexity analysis, space complexity analysis. So this is our complete program. We are already got the correct result. So let us understand how the code is actually executed. So here what happened? As we know from the main, the execution starts. So here one array is declared with the 50 elements. For example, this is 0, 1, 2, 3, 4. So on it is 49. Total number of elements it can store the 50. Then another variable we declare n, then I, then j, then 10. So please enter the size of array. So for example, I enter the size is 5. So what is the n value? N value is 5. For I equal to 0, I less than equal to n minus 1, I plus plus. So what is the initial value of I? Is 0. So what it happened? Scanf ampersand of A0. So A0 what we store? For example, I enter the element that is 25. We store the value of 25. Then I value is incremented. So we store value, for example, 15. So this loop will continue for up to how much? N minus 1 means up to 4. So then we store the value of 60. Then we store the value of 45. Then I store the value of 5. For example, now printf before the sorting the elements are. So what happened? I value again initialize with the 0. Then it print the percent of. So output, for example, this is our output string. So what it will print before the elements are 25, 15, 60, 45, 5. So the elements are printed. So this is actually main tax. So you have to understand this is the main tax, sorting the algorithm. So here what happened? So in this case, what happened? We have to start I equal to 1. So what is the I value right now? So I value right now is initialized with the value of 1. I is less than n minus 1. What is n? 4. 5 minus 1, 4. Yes, it is true. Then what happened? Temp store of AI. What is the AI? That is 15. So temp store which value? 15. Why? Because we assume, initially we assume this is the sorted array. Means the entire list we divided into two parts. First part it consists of 0 index and we assume this is the sorted one, this one is the unsorted. So from unsorted one, we have to take the first element and put into the proper place. This is the logic. That's why we store the temp equal to AI. So now temp store which value? 15 value. Then j is equal to I minus 1. What is j? I. I minus 1 means 0. While j is less than equal to 0. Yes, it is true. And AJ means A0 right now is greater than 10. What is A0? 25 is greater than 15. If it is true, then what happened? We have to perform this operation means AJ plus 1. J is 0. J plus 1 means A1. Store which value? 0 value. So A1 means this one. Now this one store which value? This value. So what is this value? AJ value is 25. So now 25 store which location? This location. Then j minus minus. So j minus minus means right now 0 minus 1. It will go to ending bracket, go to the starting curly bracket. So this condition is false, means while loop is not executed. Then a j plus 1. What is j right now? Minus 1. So it is incremented by 1. That is, right now it is a0. A0 store which value? That is 15. So now 15 we have to store which value? Inside the a0. So now this value is store which value? 15. So now if we observe that, we found that right now two elements are sorted. So what happened? From unsorted data, we have to take an element, put into the proper place. So here what happened? It is done. So now this is our, after first iteration, what happened? Now this is our sorted one. So here, then I value is incremented by 1. What is the I value right now? 2. 2 is less than equal to 4. Yes, it is true. If it is true, then what happened? Temp stores the value of AI. What is the I value? 2. So store which value right now? So right now, temp store which value? 20, sorry, 60. Store the value of 60. Then j equal to I minus 1. What is I? I is 2. If it is 2, then 2 minus 1, that is j value is right now 1. Then while j is greater than equal to 0, 1 is greater than equal to 0. Yes, if it is true, then we have to check the next condition. Aj means A1. A1 is greater than the temp value. No, it is not greater than the temp value. If it is so, this condition is false right now. This condition is false. If both the condition is false, then what happened? This loop, body of the loop is not executed. Now, this value is executed. What is a j plus 1? What is j value? 1. 1 plus 1 means a2. A2 stores which value? Temp value. What is temp? 60. What is this? So it will store the value of 60. So now what we observe that now three elements are right now is sorted order. So three elements are sorted right now. They need to go to the ending curly bracket. It will go to the starting bracket I plus plus. So I value is 3. 3 is less than equal to 4. Yes, it is true. If it is true, then the body of the for loop is executed. Now temp store which value? AI. What is the I? 3. So what is AI? 45. Now temp store which value? 45 value. Then j is equal to I minus 1. What is I? 3. What is j? 3 minus 1, that is 2. Now, while j is greater than 0, yes, 2 is greater than equal to 0, yes, it is true. If it is true, it will check another. aj, a2 means 60. 60 is greater than 45, yes, it is true. If it is both the condition is true, then what happened? The body of the while loop will be executed. What is the body of while loop? Aj plus 1. What is j? 2. So A3 store the value of A2. What is A2? 60. Now 60 store which place? 45 place. So now 60 store here. Then J minus minus. So J value is decremented by 1, that is 1. Now this is 25. It will go to this plus. J means 1. 1 is greater than equal to 0. Yes, it is true. Now this condition is true. AJ means A1. A1 is 25 is greater than 45. No. So this is false. If one is true, another is false, then the while loop is not executed. So what happened? A J plus 1. J is 1. 1 plus 1, 2. So A2 store which value? 45. So now this value store the value of 45. Now we just see 15, 25, 45, 60. So this elements up to this is the our sorted part. This is only unsorted part. Now it will go to ending curly bracket, then starting curly bracket. I value is incremented by 1. That is 4. 4 is less than equal to 4. Yes, it is true. Then temp equal to AI. What is temp? Right now AI. I value is 4. A4 is 5. So now temp storage value 5. Then J is I minus 1. What is I? 4. 4 minus 1 means it is 3. Then J is greater than equal to 0. Yes, it is true. And AJ. AJ means A3. This value is greater than temp. Temp is 5. Yes, it is true. If it is true means J plus 1. That is 3 plus 1. 4 store which value? 60. So now we have to shift this value to this one. So here we store which value? 60. Here also right now 60 is present. Then J minus minus. J is 2. Ending curly bracket. J is greater than equal to. Yes, it is true. This one is AJ. AJ means A2. A2 which value? 45. 45 is greater than 5. Yes, it is true. If it is true, then what happened? AJ plus 1 means 2 plus 1, 3. Store which value? This value. So now this value store value of 45. Then J minus minus, that is 1. Ending curly bracket, go to starting curly bracket. J is 1 is greater than equal to 0. Yes, it is true. Then AJ means A1. What is A1? 25. 25 is greater than 5. Yes, it is true. If it is true, then what happened? AJ plus 1 means J is 1. This value means this value is restricted to this location. So what happened? We make this one as a 25. Then J minus minus. J minus minus means this is 0. J is greater than equal to 0. Yes, it is true. 0 is equal to 0. AJ means A0. What is A0? 15 is greater than 5. Yes, it is true. Then what happened? AJ plus 1 means 15 store in this location right now. So now 15 we shift to the next location. Then I equal to minus 1. Go to ending curly bracket. So this condition is false. J is greater than equal to J is minus 1. This condition is false. If this condition is false, it will not check the another condition. So after that, a J plus 1 equal to temp. What is J? Minus 1. So minus 1 plus 1, A0 store which value? 5. So A0 means this position. So now this position store which value? This store the value of 5. Now just see 5, 15, 25, 45, 50, 60. So all the elements are sorted right now. After that printf, after sorting the elements, a equal to I equal to 0. Now what happened? I equal to 0, it will print AI. What is the AI? 5. Then it will print the second value 15, 25, 45, 60. We are already completed our implementation part right now. We are already got the correct result. So let us discuss the time complexity. So time complexity for the best case, it is order of n because we have to go for the list where the data is already sorted, where a number of the list. So order of n means n is the number of elements. If the elements are already say sorted, then what happened? So for outer loop, we have to only the traverse. For inner loop, that is the j equal to j is greater than equal to 0 and aj is the greater than the temp value, it will not ask, it will not execute because the data is already sorted. So that's why the best case is order of n when the data is already sorted. Next one is the average case. Average case is the order of n square because it is the elements are in stored in a arbitrary order or randomly. So here what happened, both the inner loop as well as the outer loop will be executed. Worst case, if the list is in reverse order, we are already executed The last example, that is the all the elements we store, that the reverse 100, 99, 88, 100, 90, 80, 70, 60, 55, 44. Next one is the space complexity. So it requires additional space, making the space efficiently for the sorting algorithm. That it is only require only one constant time. That's why it is space complexity is order of one. So in case of advantages, what are the advantages of this algorithm? It is very simplest algorithm to implement, and also it is very efficient for a small size of dataset. If the larger dataset, it may not work properly, and the algorithm is stable. It means whenever any changes occur with the any key, then it also perform the same. It will not perform the result, does not change it. It can sort a list when it receives, hence it is more flexible. Means whenever one element is added, it can be flexible to make the newly added element into the proper position. Next one is the disadvantage of this algorithm. So this sorting algorithm cannot perform well with the large data. It is only for small size data set, so it is inefficient for the large set data. It is not that much efficient like the merge sort algorithm, quick sort algorithm for the most cases, because maximum time we require day by day our data sets are more, so we cannot perform with the current demanding data sets. Next one is the what are the application or what are the areas we can use it. We can use for the bucket sort also. It can be used for the almost sorted on some array. Then we will can go use the so about this algorithm because it is very flexible for the some small size data set. Here what happened in case of hybrid sorting algorithm, when our when the sub array size has become too small, at that time we switch over to the insertion sort. Like in case of quick sort or merge sort, we can use it. For example, otherwise we can use in case of intro sort or team sort, we also use the insertion sort algorithm. Thanks for watching the video. Hope you are able to understand the concept of insertion sorting algorithm. Please subscribe the channel, like the channel, share the channel. Thank you so much.